Okay, we are moving along in 8M3. We are in 8M3. Lesson 3. 8M3, Lesson 3, examples of dilations. So again, dilations is a transformation in which you make something bigger or smaller, but you leave it the same shape. So you take a rectangle and you grow it, or you take a rectangle and you shrink it, but it's still the same shape and size. You could take a triangle, you could do a circle, but the key is that you, the key that we learned from lesson 2 was that if you take a polygon, that you simply take all the vertices and dilate each one relative to your starting point. And if you're dilating by 2, you take each vertex and you take a ray to that vertex, and then you double it if your R is 2. And then after you've dilated all your vertices, you draw your new object. And your new object, if R equals 2, each aligned segment, each side will be twice as big as the original. If you shrink your object by, say, 1/3, then each of your new line segments dilated will be 1/3 the length of your original object's side length. So let's move on. We're going to talk today. We're going to do 2 things today. Let me just let's just cut over to the drawing pad and we'll actually write them down. And these 2 things that we're going to learn today are how to dilate objects that are not polygons. So you can't simply take the vertices, dilate them, and then draw your new object. The second thing is how to know how to get back, in quotes, to original object after dilating. Remember, so let's just look real quick here, and we'll go back to our if we can remember back to 8M2 translation, and we took like an object like a triangle, and we translated that guy. So if we were to have we translated that guy along this vector here, we would have got our new triangle by, again, we would take our object here. Right, we take our object and we translate each point to our, our new triangle, and we would take we'd take our object here, and we would take each point. Oh, there we have that problem again. And we just translate each point, and we translate them here. I'll just draw this thing back in rather than go through the, we had our vector, and then we'd have our new triangle. Now, the whole key was to get back to our original triangle. We would have to translate back along a vector or array that is in the opposite direction and the same length. And so this is our our original vector or array, and then this is the one that would return to original. And we're going to learn, we're going to learn how to return our original object after dilating. What is the rule to get back to our original object? So again, this is for translation. We're going to learn the rule for dilation, how to, after you shrink or grow, you grow something or you shrink it, how to get back to the original. Okay, so those are the 2 things that we're going to do. Now, we're going to go back and we're going to use GeoGebra again. And that is going to be our tool for dilating a circle and for dilating an ice cream cone. And you'll see what I mean here. So we're going to dilate this circle here. So I'm going to show you how to dilate a circle. And then we're going to, and when I say, and we're going to use R equals 3. So when I say R equals 3, that means our scale factor is 3. So what does this imply? I want you should be able to tell me whether this means we're growing or shrinking the object. Right? And so for those of you that said growing, you are absolutely right. So what we need to do is we are going, the process, the procedure why did that happen? Okay, the procedure for dilating is to a non-polygon is to simply dilate enough points and sketch. Why does that happen? Okay, we're just gonna go here, sorry about that, and sketch the new object. Sometimes you can make a perfect new object, sometimes you can't, and we'll see how that works. Well, let me say that on a circle, if I were to just let's just pretend we're going to dilate this circle using R equals 3. So let's dilate our point B, because we know point B is one of our points on a circle. So let's dilate that point. And so when we dilate it, if R equals 3, we got to go along this line 3 units. Now, what you're going to do is you're going to use a ruler on your graph paper, and you're going to measure this length, and then you're going to take it out 3 times. Right? So you're going to measure this length, whatever this length is. You're going to take this length, and you're going to measure it and go out 3 times. 1 time, 2 times, 3 times. And I know from doing math that that exact spot is going to be right here. I've measured it, and it's going to be right here. We're going to rename that point to point B prime so that you can see exactly which one it is. So I've dilated point B 3 times and got to B prime. But can I draw a circle, my new circle, using B prime? Well, no, because I don't have enough points to know where to make the circle. So let's choose a few more points on this line. Let's choose this one. And let's choose this one, and let's choose this one, and let's see if that makes enough points. Okay, so let's make our dilation. We're going to dilate point I. Well, it turns out that I is also on this line, so we have to go 3 times this distance. So if it's this distance, I know that I'm going to measure this, and it turns out that my magic point is right here. I've used my ruler, and we're going to now look at that point, and we're going to call that one I prime. Right, point I maps to point I prime. Okay, well, let's keep going. We got to dilate point G. So we have to make our line here. And I know that that point is, I'm going to take my magic ruler, and I'm going to make my point out here, and it's going to be right here. And we're going to label that point. What are we going to label it? We're going to label it G prime, right? It's our dilated point G 3 times. And we're going to do one more time. We're going to dilate point along point H about point F. And our point is right here. Now, I think you can see, we'll call that H prime. I think you can now see about where our circle is. Well, it's going to be something like this. And we know our center's here. Our center's right in the middle of all these points. So let's go ahead and make our circle. So notice we've dilated our 4 points and we have a circle, and it's in this circle is 3 times bigger around. It's 3 times, we've dilated it 3 times. And we needed to choose enough points so we can kind of see what our circle is. Now let's look at our ice cream cone here, and let's dilate our points. Let's dilate this one using, so let's, that's pretty good. Now we're going to dilate, our ice cream cone with an R equals 1/2. So are we shrinking or growing? R equals 1/2. R is less than 1. So for those of you that said shrink, you are right, because each line, when we make our rays, we're going to go only halfway along the line. In this case, when we dilated, we had to make our lines segments 3 times longer to get to our points. Here, we're going to go halfway along each line, and I'll show you what I mean. It's the same procedure. Okay, so we're going to take out our ruler, and we're going to measure along this line. Let's just make all of our lines right now, because they're easy to make right now. And up here, I'm going to go ahead and take away, our lines, because we don't need those anymore. Oh, whoops. Dang it. What happened? Oh, I deleted the wrong thing. Yeah, so let's go ahead and make our circle again. It was like this. Yeah. Okay, so down here, I'm going to dilate C into a point C prime. And so I take out my ruler, I measure from this origin to here, and I take half of that length, and I come out with a point right here. And we're going to label that one C prime. Do the same with E. I'm going to measure this line, take half of it, and I'm going to come out with a point right here. And that one's going to be E prime. Now I'm going to take another point, D, take half of that. I'm going to come out with a point right here, and we're going to call that D prime. Well, I don't really have enough information here. I can't really redraw this object quite yet. So let's choose one more point, a smart point maybe along here. Maybe we choose this point right here, right on top. Yes, this is going to be the one. And if we take a point halfway along here, it's going to be right here. And now I think I can draw my new object. We're going to draw a semicircle like this, and then 2 straight lines from here to here. So let's go ahead and draw those lines. There's my 2 sides. And now I'm going to draw my semicircle, and I'm going to say a semicircle through 2 points. We're going to take this one and that one, and there. We have dilated our ice cream cone by r equals a half. And you can do like, you may have some objects that are even more complicated. You may, whoops. You may need to use 5, 6, or 10 points if object is more complicated. Okay, so we'll just put a line through that, a line like this. Okay, so now the last question is this. If to get from this object to this one, we needed to multiply by 3. Our r is 3. This is 3 times bigger. You know, our bigger circle is 3 times bigger. How small, if we want to go backwards, how do we go back? How do we go back? Well, the question is how much bigger is this circle than this one? If this one's 3 times bigger, I want you to think about what takes us back. How much times smaller is this one? Well, those of you who said a third, you are absolutely right. It's a third. We grow it 3 times. We have to then shrink 3 times, right? If I have $10 in the bank and I triple the amount of money, I have 30. If I have $10 in the bank and I multiply by 3, I get to 30. So to get back to 10, I have to multiply by 1/3. That takes my 30 back to 10. And notice, what is true about these two numbers? They are what? Well, while you think about that, let's think about this other problem. If we dilated by a half to get from here to here, that's times a half. How much bigger is this ice cream cone than that one? All the line segments are twice as big, right? If that is half the size, right? If I have a bank account with $20 in it and I shrink it in half, whoops, times a half, then to get from 10 back to 20, I multiplied by 2. So what's true about this number and this number and this number and this number? 3 1/3, 3 to 1/3, a half to 2. You have reciprocals. Right? So we're going to write this rule back on our sketch pad, but the key is reciprocals. So if this one is 3 times bigger, to get back, I use that same point of dilation, but I multiply by 1/3. It's reciprocal. Likewise, if I multiply by a half, the reciprocal of a half is 2. Now let me ask you, we're going to go back and we're going to write this on our sketch pad. This is the answer to number 2. To reverse our dilation, use the same point of dilation, often the origin, but use a scale factor equal to the reciprocal of the first scale factor. right? So if our original one was r equals 3, then to get back, we use an r equal to 1/3. If our r is equal to 1/2, to get back, we have to, that was a shrink, we have to grow it with an r equals 2. If r equals 1/10, we shrunk it by 1/10. To get back, we have to grow it by 10. Now, the final question, and this is homework help, by the way. This is homework help. What if r equals 3/2? Well, that's greater than 1. So we grew something, and we grew something by 1.5, which is equal to 3/2. It grew 1.5 times. So for those of you, if you pause and try, what is the reciprocal of 3/2? Give yourself a big happy cat if you said 2/3. You can give yourself a big happy cat or just a little happy cat, depending upon how much space you have on your paper. But right, if I grow something 3/2, to get it back to its original size, you have to shrink it to 2/3 of its original size. And we will leave you with that thought. We learned 2 things today. We learned how to dilate objects of random shape and size, and then we learned the rule for what you have to use for a scale factor to return a dilated object to its original shape and size. If this was useful, give me a clap. Thank you. I love the clapping. And we'll see you next time with 8M3L4. I'm sure it has to do with dilations. I got to check it out, but I will be delivering that soon. Happy mathing.